Hi everyone. Wherever you are on this planet, I hope you and your family are staying safe and doing well. Here's a little message on my shirt. We'll all succeed in this time of uncertainty. Let's get into business. The STEM certificate program has pushed me to go above and beyond a high school curriculum to dive into my interest in science with experiential hands-on learning. I have spent my last 2 years exploring different domains. My first major STEM project was Project Pomfret 2019. I learned to create a physics simulation in virtual reality by using Unity and C# programming for an HTC Vive headset. In the simulation, the user can teleport around and grab and throw an object. With a display of the object's height, distance travel, and velocity, the user can investigate vertical kinematics motion and the conservation of mechanical energy. I truly appreciated the trial and error process of a programmer, the frustration when the "you must compile error before running" line pops up, the confusion of not understanding where an unexpected error comes from, and the fulfillment of finally getting it to work after hours of attempts. It was very satisfying in the end to see people coming to try and mess around with a VR simulation. I've always been amazed with how VR transcends physical barriers to aid scientists, like constructing 3D visualization from 2D CT scans for doctors to accurately identify tumors. So I was really grateful for the project. In summer 2019, I interned in a biochemistry lab at the University of Missouri St. Louis through a program called STARS. Don't worry about the technical words on the slide, it's just my introductory slide for my presentation at the end of the program. Utilizing a machine called mass spectrometer, I researched the molecular structure of various petroleum compounds. I also developed a computer program that can automate some of the data processing work. I absolutely fell in love with the rigorous and collaborative environment in the collegiate research lab. I gained great insight into the lives of graduate students and professional researchers, and I realized that doing long-term research can be often arduous and disappointing, but very enjoyable and fulfilling in the end. The difficulties and joys I went through made me more appreciative of scientific discoveries and encouraged me to pursue scientific research in the future, although I don't plan to major in biochemistry. Besides these two, I spend most of my time with astronomy, my biggest passion. For my STEM certificate program showcase in the Fall Family Weekend, I researched and presented about gravitational waves, which are disturbances in space caused by accelerating astronomical objects, similar to how ripples propagate across the water when a rock is thrown into a pond. Predicted by Einstein in the general relativity in the 1910s, gravitational waves were finally detected and confirmed in 2015, providing astrophysicists new pairs of eyes into objects like black holes and neutron stars. It was a truly stunning discovery, which led to an entire new exciting era of astronomy research that I hope to be a part of. Apart from that, throughout the independent study-based computer coding elective in the winter term, I took the online course Data-Driven Astronomy offered by the University of Sydney, a great crossover between data science and astronomy. For my first case study, I developed algorithms to stack multiple radio image files and determine if the object in the image is a pulsar, which is basically a rotating neutron star. For my second project, I wrote a program to cross-match galaxies in a radio survey and their counterparts in an optical catalog. I learned not just to code something that works, but to optimize the algorithms by avoiding redundancy, minimize code execution time, and reduce the memory storage occupied. Programming and data science will become powerful tools to manage and process an overwhelming set of data tracked in real time, which is typical in astronomy research. Beyond that, I initiated two independent studies in astronomy, one on black holes in spring 2019 and one on modern cosmology topics right now. I got to explore so many different domains like relativity, particle physics, dark matter, and dark energy. Like I and Mr. Lake frequently mentioned in our conversation, what a fascinating time to be alive for astronomy buffs. We have all these sophisticated technologies like particle accelerators that make new fields of astrophysics research possible, yet there are so many mysteries to chase after. I know for sure I want to pursue astrophysics as a vocation, not just a mere subject or a future job. Last but definitely not least, I was lucky to spend my last 2 weeks at POMFET working on an observatory automation project for Project POMFET 2020 with my close friends. We have synchronized the dome with the telescope in the Olmsted Observatory by recalibrating the system and debugging the software. This enabled the dome to automatically track the telescope instead of being manually rotated. With my close friends, it was a lifetime memory filled with joy and laughter, which concluded my on-campus POMFET career on a high note. I really appreciated all the opportunities and experiences I have had in the last 2 years, which have shaped my college major interests and career pathway in the future. Thank you so much for watching my STEM certificate capstone video. Have a nice day.